Take your seats, please. A few of you still standing. Okay, so thanks very much, everybody, for getting back on the new timescale promptish. This is our last session today, and we've got a couple of topics to talk about in this last part of the day. Something around the topic of interruptions to supply, which we've kind of touched on recently, and achieving zero interruptions, and then some news on leakage-related Ofwat Innovation Fund projects. But to start the session, I'm going to hand over to two colleagues from United Utilities, Dr. Sam Fox, who is Head of Integrated Network Strategy, and John Birkhead, who is Water Network Strategy and Planning Manager. So Sam and John are going to lead the session on a presentation entitled Resilience at What Cost? Managing Water Infrastructure Assets as we aim for zero supply interruptions. So where are they? They're here. Over to you.
Super. Thank you very much, and afternoon, everyone. Right, the notes for this session says it's an interactive session. So we're going to make it interactive. So be warned, there's some questions and polls that I need everyone to input. So if you haven't got your phone out, get ready to get it out later. Don't get it out just now and start ignoring what we're going to talk about. So just by way of introduction though, as Bob says, so I've got two roles. I lead our water and wastewater network strategy teams at United Utilities, so very much got the water hat on today. But also the big question lead for how do we achieve zero supply interruptions by 2050. It's a massive challenge, but one, if you don't have a big ambition, you're not going to get anywhere. So really what we wanted to do today is really try and answer some of this question, resilience at what cost. I'd love to say I can stand here and have got the answer for the industry on how we deliver long-term resilience, be that long-term resilience for leakage, water supply interruptions, water quality. This is part of that, and actually is a really nice lead on from what we've already talked about this morning. Actually, what I'm going to be doing is probably just reinforcing some of those headline figures, key areas that we're focusing on from what Joe and others have talked about as part of the leakage route map and those activities. Before I sort of start talking a little bit about the kind of bigger picture of resilience, asset health, mains renewal, what does this mean? How do we do it effectively? How do we take into account customers' views on it? I've asked John, who works in my team, to come and just talk a little bit about the transition we're going through as a company at United Utilities around our leakage strategy. So I'll hand over to John just to start off the presentation.
Right, good afternoon, everyone. Yes, I'm John Birkhead. I'm Water Network Strategy and Planning Manager at UU. So I'll kind of go through how this kind of question fits in with our leakage strategy in AMP7, AMP8 and beyond. So yeah, next slide, please. Oh, the clicker. Oh, sorry. Oh yeah, there you go. Okay, so as with a lot of leakage strategies at the moment, we're kind of using the PALM model to explain it. So these are the kind of key elements to our strategy going forwards. This kind of fits into a wider strategy around reducing water demand, so it's called our leakage strategy, but it's very much a kind of water demand reduction strategy. It's kind of, yeah, as I said, it's kind of in the PALM model. What we're trying to achieve at UU is this kind of movement from find and fix to what we've termed dynamic network management, but it's just the kind of move from locate and mend to prevent and aware, so much more on the leak prevention side. So that means that a lot more activity around kind of calm networks. We already have a lot of pressure management, but maintenance of our pressure management. Through AMP7 we added remote capability, so it's building on kind of that remote capability and what it can tell you about kind of the need for maintenance of pressure management valves. And a big area which we're focusing on at the moment is kind of water network asset health. Which is why it kind of fits in with this question on how do we achieve an up in the rate of water network mains renewal. We're also combining this with, we're kind of aware that we'll still need to be doing find and fix, so we're kind of combining it in with a strategy around smart metering. So I'll talk through some of the specific elements of the strategy around smart metering and some of the work we're doing on locate and mend. Okay, so this is the same kind of strategy slide, but with just a bit more detail on what we're kind of looking at in terms of maintaining leakage and then the planned leakage reduction over AMP8. So it gives you a bit of an idea of our percentage reductions in the top, but broadly it's a 50 megalitre a day leakage reduction. And where it's coming from is a smart metering programme, so about 1 million household and non-household smart meters going in the ground over AMP8. And we know that then comes with a massive sort of data analysis burden or data analysis need, as well as kind of a complete change in how we kind of engage with customers around what's been spoken about already. So customer side leaks, plumbing losses in properties. So that's one of the major parts of the strategy. We're doing additional work on kind of pressure optimization. So that's around optimizing our DMAs, but also optimizing the pressure management valves we've got in our network. But a lot of the kind of leakage reduction we've planned is to come from replacement of water mains. So 695 kilometres of water mains, which fits into our wider programme of just under 1,000 kilometres of renewal. So that's why we are posing some of these questions that Sam's going to talk through, because it's a really critical element of our programme in AMP8, and kind of we don't really see a way to halve leakage by 2050 without a lot of this activity kind of around mains renewal. The other thing, combining with the smart metering, the other thing we're doing is looking at a kind of live mass balance across the system. So we've been working on incorporating the data from our network meters, DI meters, so distribution input meters, and the customer meters. So as they become smart meters, we're doing a kind of we're aiming for a live mass balance across the system. So we've already started to develop that platform in house. So yeah, like I said, the strategy is to move kind of away from find and fix, but kind of acknowledging that there's a bit of an overlap between kind of aware and locate. So as we, especially around kind of smart metering, that can sort of support with location, and as the technology improves on the kind of in the network sensors, automatic correlation may help with the location question as well. And a lot of the focus on mend is around how we prioritise based on customer impact or size of leak. So we're doing quite a bit of work in terms of trying to understand the size of leak so we can better prioritise the repair jobs. And then the other main piece of mend is the no dig and kind of in-pipe repair technique. So yeah, that's the other focus for mend, is kind of the kind of reducing disruption, and that also ties in with what we're talking about for mains renewal. So yeah, that's broadly our strategy. So you can see the kind of strapline digitally enable our water network to provide first-class service at the lowest whole life cost. So that's kind of the aim. But this is a bit of context to the wider discussion on how we deliver mains renewal without the supply interruptions impact.
Super. So when we were coming up with this strategy, we had to think about what was our priority. And one of the key things we wanted to focus on was how do we get this balance between long-term investment and short-term performance-driven activities. So asset health was a kind of key priority. So my first interactive question for you all, I'll need everybody to get the phones out. And I will happily stand here and watch everybody get their phones out. And we're going to move to a Slido poll. What we want to do, and this is links to part of the MEND work stream that Joe talked about earlier. We want to get a view of what are the priorities for everybody. What do you see as the number one priority to drive leakage improvements? And I've put on this just in AMP8 to start with. So what I'd like to do, and if you want to do this on your own or have a little chat with those on the table, start feeding in some of those words. What are the things that spring to mind? What are your number one priorities? We've heard lots of things spoken about this morning. Some of it is data. You know, Ian's challenge to us all around data. Is it estimation? Is it calculation? The challenge around how we use those systems, how do we optimise where we target mains repairs, etc., etc. So it's great to see people are feeding in lots of words in here. Hopefully, if people are saying the same words, we should see bigger text for those repeated terms. So smart metering obviously is taking front and centre at the moment. Reduce runtime, smart networks, fantastic. Super. So by all means, please keep filling that in. Because what we'll do is, I want to take this as, this is live customer research or client research, or whatever you want to call it. This is going to feed into this kind of shaping some of those route map activities going forward. And actually really getting a view from experts across the room, from various different walks of life, what they see as kind of key priorities for us going forward. I'm thrilled somebody said targeted mains renewal, because it would have been really awkward if nobody had said mains renewal for the rest of the presentation. But one thing that always strikes me when I ask these questions is around the kind of temporal scale and the time scale of some of these activities. Some of these things are quick wins. Some of them are far more drawn out activities. I see somebody put the word speed on there, which links really nicely if we can flick back over to the slides. So I always like, whenever I do a presentation, of coming up with a terrible analogy. So here is my terrible analogy. There are two different trains of thought, I think, of how we can tackle leakage. There's fast-paced, accelerating towards leakage targets that we set ourselves on a monthly and annual and in-amp basis. But there are always hurdles in terms of how we need to deliver that performance. They may be technological hurdles. They may be something in terms of the environment in which we work in, whether it's an urban environment, a rural environment. So I've kind of summarised that by saying, well, that's like the 100-metre sprint hurdles. We know where we want to get to, but actually it can be quite hard to get there based on some of those hurdles we've got. And I was thinking, well, how do I represent that long-term view then? So long-term might be around those asset health improvements. Smart metering, it's going to take time to deliver increased meter penetration and build on those data sets and our understanding from that. So I said, well, that's equivalent to the steeplechase. You've still got those hurdles, and because it's taken a little bit longer, you might get wet along the way. But actually, the sweet spot for what we need to deliver is a balance between these two things. You can't just deliver long-term improvements and hope that your short-term performance is going to be dragged along with it. So one of the key areas of focus for us that John sort of talked about is finding that optimum balance between the sprinting and that long-term middle distance running. Equally, both sides will have lots of hurdles that we've got to overcome. And actually, one of the things we've kind of contemplated is how do we decide on optimal investment, not just with a leakage lens. I think Joe alluded to this earlier. We can deliver certain activities that will drive performance on leakage and supply interruptions, but what does that mean for water quality? What does that mean for areas of poor pressure? Ultimately, what does that do in terms of driving down our reactive maintenance spend, the number of mains repairs that we deliver? So again, we came up with this concept at UU where we like to have, as I say, an analogy or a concept for everything. Where we said, actually, let's think of it as a roundabout. So we've got lots of lanes that are all coming into that central space, which is asset health, and trying to pose that question of how do we deliver optimal investment to improve asset health that delivers both short-term benefits to driving that leakage performance that we're going to be hopefully committing to in AMP8 as we go forward with PR24 determinations, but actually also considering what the wider benefits are. So water quality contacts for us in the Northwest is a real challenge, primarily based on the source water. We're predominantly a surface water fed supply area. So discoloration contacts is a real challenge. So how can we drive targeted investment that improves leakage but also improves the quality of water that customers are receiving? Interruptions to supply. Some of the research we've done with UCWA and with RPS recently, if you look back over the last 10 years or so, over 60% of all water supply interruptions are as a consequence of the quality and the asset health of our network. And that might be linear assets, it might be point on linear assets, so PMVs, valves, etc. So again, how do we target asset health to make sure we're minimising the future disruption that we might have for customers? And then equally, and it's particularly prevalent in the Northwest, supply and demand growth. How do we make sure that we're actually delivering the investment we get and through developer service charges, not just to prevent deterioration, but how do we balance that and optimise that with our own investment to really drive improvement in the health of our asset base and improve performance in all of these metrics? So really kind of those key points, it's performance improvement. We can't just look at this as a long-term game. So how do we balance off those short-term performance requirements with that long-term asset stewardship that we've talked about? And ultimately, that challenge on how do we optimise investment. There's a second poll then on here, so we'll flip back over to Slido again. So I've asked you the question of, what's your number one priority for driving leakage improvements in AMP8? So this second question is, continuing that analogy of the hurdles, what do you see as the biggest hurdles to delivering a resilient water network? And I've intentionally not put a timescale on that. So have a think, type it in. Funding, a clear challenge. You know, Joe's already articulated some of the scale investment that companies have put forward in AMP8 for delivering mains renewal. That brings with it its own challenge of affordability. You know, how do we make sure we're delivering performance improvements, asset health stewardship that doesn't necessarily disadvantage customers from an affordability perspective? So a whole range of different answers I think we've got on there, which is great. There's one word on there which is really good to see that I'll come on to. So if we flip back over to the slides again. So we've already talked about this, and what's great is doing a presentation where the headlines of your presentation have already been delivered, because you can just reinforce that message, which is brilliant, and actually a really kind of pertinent point for me, which I'll explain on in a little while. So asset health, we've said we want to invest in asset health. We've said as a sector, there's 8,000 kilometres of mains renewal we want to do in AMP8. Brilliant. Right, so that's going to bring down a lot of that planned activity, so we're going to have less reactive mains repairs in there. But there's a few things we need to consider when we're looking at that. And one thing I'm always conscious when I'm in an audience of very technical expertise and things, we often don't put customer first when we think about the considerations that we've got. You know, before we jump to what the solutions are, what's the regulatory environment that we need to work within, where are we going to live this, what do customers want, what do they say to us? So I'll come on to that shortly. The second, obviously, is that regulation, the environment that we're in. You know, funding, Ofwat, etc., are some of the kind of key terms that came through on the Slido that we just went through. Absolutely, and there are commitments that we've made. There's expectations from the regulator. The 0.4% infrastructure renewal per annum is a kind of key area at the moment that's been talked about quite widely. And then beyond that, there's the solution. So what are we actually going to deliver? So it's great saying we've got that 8,000 kilometres of mains renewal, mains rehab. There is a commitment, or an ambition, I should say, at this stage. But what are we actually going to deliver for that? So what I'll do then, I'll come back to customer. So as a water company in the Northwest, we've got 7 million customers, and as part of the price review and preparation for PR24, we asked customers what they thought about their priorities or expected levels of service, and water supply interruptions was a key component of that. So we asked them about reactive incidents, what did they expect, and unsurprisingly, well over 90% said, well, their main priority is getting the water back on as soon as possible. What we also did was we asked them, well, what are your views on planned work? Because at the moment we've already had referenced this 3-hour threshold that we're currently regulated on, which obviously informs and drives the way in which we operate and deliver planned rehabilitation or any kind of planned activities across the sector. So we said to customers, what do you think if we gave you, as a minimum, 48 hours notice around planned interruptions? What's your view on what the priority is within that? What they actually said to us was, one is, well, can you give us a bit more than 48 hours, which I think is a perfectly reasonable response to that. What they then said was, well, actually knowing how long the water supply is going to be off for is our number one priority. What they then also started talking about was, they said, well, actually, if you can deliver with a longer outage, more innovative solutions that are more cost effective, which is not something we immediately think of when we ask customers their thoughts on this, then we'd be supportive of a longer interruption. And those interruptions range from about 5 to 8, 9 hours was what they said they'd be supportive of with that. And one of the things we've kind of framed is we need to get out of this mindset of we talk about water supply interruptions very, very simply as when does the water go off and when does it come back on again. Now that's fine in a reactive space, because actually it is about getting the water back on as quickly as we can do. And that's what customers have said the number one priority is. From a planned perspective, there's a whole other lens to it. I've put these two pictures up on top of here. Neither of these pictures have anything to do with when the water's off and when the water's back on again, in a planned environment. Actually, one of the key things for customers is not the interruption, it's the disruption. You see on the top right there, not having access to come out of your house, potentially the people who park their cars there. Actually, that disruption can be more significant than the actual interruption. So again, what we've got to try and work out is, what's this balance then between customer interaction in terms of what they value and how quickly they want the water on. Joe made a really important point that we've got to make sure that we're considering our priority services customers. There might be customers who any length of interruption is a no-go. So what plans can we put in place to mitigate that risk? But also let's have a think about some of the other kind of broader disruptions. So are there technologies, techniques, which means we don't have to have 12 sets of traffic lights, which mean your school run takes 4 times as long and you've got screaming kids in the back of the car. So there's a broader customer dynamic to this, not just when's your water off, when's it back on again. Now regulation at the moment does drive the way in which we deliver planned activity. If you look at the water supply interruptions associated with planned work across the sector, it's quite low, but it's quite low because we target that. We look at ways in which we can deliver planned activity, whether that be in infrastructure renewal or any other activity, adhering to that 3-hour window. What that has meant is that infrastructure renewal rates over the last 10 years are probably at an all-time low compared to where they were historically. Certainly from a United Utilities perspective, we've not done a huge amount of renewal since about 2010, because actually we had really significant programs primarily focused on water quality up to 2010, and then have targeted other assets, so service res inspections and remedial activities since then. So how do we create an environment in which we incentivise and improve that ability to deliver greater levels of planned work going forward? As Joe said, it's a step change, that 8,000 kilometres, but it's a drop in the ocean in terms of what we actually need to do going forward. So this has got to be the start rather than halfway along the journey in terms of that change going forward. From a regulation perspective, and Jez has already mentioned this, we've said, well, actually, we've listened to customers. We've acknowledged what they've said to us about the balance between planned and reactive interruptions. We understand sort of the timescales that they'd be willing to accept if we gave them good proper notice, a couple of weeks notice on things. So actually what we've submitted as part of our business plan is saying we're going to commit to or propose around 650 kilometres of mains renewal, where actually that mains renewal will be excluded from the 3-hour window, and we'll include a new 8-hour window. Because actually we think that can be anywhere between 50 to 150 million saving in terms of the cost to deliver that, based on the additional overland feeds we'd need, traffic management, etc., etc. And that's before we've even considered the kind of customer disruption element of that. Now that's great. That's what we've said, that's what we want to do. That's with Ian and colleagues to sort of debate and mull over that over the next few months, and we're certainly more than happy to engage with those conversations. Part of the reason I come and do these talks is because this can't just be in IT Utilities area of opportunity and interest. So one of the real things for me is looking across all other water company representatives, looking at the supply chain and saying, if this is something we want and need, how do we all get behind this? And this is one of the real reasons we've brought this topic into the leakage route map under that MEND theme going forward. So actually there's one voice on this, and that one voice isn't my voice. That one voice is a sector voice for this going forward. What this also kind of leads on to then is, well, what are we actually going to do? Jez and I, in our capacities as Big Question leads for UCWIR, ran a series of combined leakage and supply interruptions workshops a couple of years ago now. And one of those was looking at the topic of novel liners. And the supply chain were involved in that, and we were really interested to kind of get their view on what are the opportunities out there, but equally what are some of the constraints. And some of those constraints at the moment are actually, well, as a sector, there is very little appetite for lots of different solutions. So there's a question for ourselves of, well, why is that? Why are we not pushing the market forward to deliver new solutions, to drive asset health, to drive resilience? Some of that is to do with, that 3-hour window. Actually, some of these solutions require 4, 5, 6 hours of curing time, for example, if it's lining. So actually that's a no-go if actually we want to adhere to the performance commitment levels that we've laid out within our business plans on an annual basis. But there are lots of other reasons, and I think one of the real opportunities at the moment is if there's 8,000 kilometres to go at, there's 8,000 kilometres for us to think about what is the optimal solution in that area. And that may be based on pipe size, pipe material, pipe location. You know, in the northwest, we've got this amazingly diverse environment where we have the Idle of Cumbria and the Lake District, and then we have Manchester and Liverpool. So actually we can't just target mains renewal in the areas that it's easy to deliver mains renewal. The game isn't just about we're going to deliver 8,000 kilometres of mains renewal as a sector. That's an easy game. The game is that asset health roundabout. How do we deliver 8,000 kilometres of mains renewal that maximises performance, improves performance and delivers long-term resilience? You know, we are accountable as asset stewards, providing a service to everyone in this room, everyone not in this room. So again, how do we optimise that going forward? So I thought I'd just finish then, just kind of bring this back to the big question. So for all the big questions under UCWER, and hopefully most of you are familiar with UCWER, but there's a link at the end of this presentation to the UCWER website, and I know Jez is going to go into a little bit more detail about leakage tomorrow. For each big question, you have a series of outcomes that you want to focus on. And these are kind of challenging, probing questions, which for us as a sector, we look at and say, well, how on earth do we answer this? You know, what's the fundamental research we need to be looking at to really drive forward our intelligence, our understanding in these different topics? I won't go through each one of these individually, but kind of in summary, what these are really focusing on, you've got areas that is focused on response. So what I've talked about so far is about that long-term resilience. But let's not be naive to the fact that we need to improve our current and existing response when we have interruptions. Leakage is not going to go away overnight. Leaks to bursts is a growing area of understanding with some of the PhDs and work which I think we're probably going to touch on over the next couple of days. So how do we get ahead of those potential interruptions? And that's great. Once we've got a response and we've got an ability to respond, whether that's a data-driven, predictive, whatever it might be, approach, how do we then restore? You know, how do we get out to the affected area? How do we restore flow? How do we make sure customers in that unplanned environment are impacted for as little time as possible? And then the last couple on here, then really focus on, you know, how do we look at the system as a whole? We operate on the system on a daily basis. There's been a move, certainly within our business over the last few years. Calm networks meant don't touch the network. But there's a real risk with that if we don't touch the network, when we then need to do something with the network's then shocked. You know, I've sat here really comfortably and then you've opened a valve and all of a sudden I'm doing something very different. So again, we're looking at a mindset within United Utilities at the moment, which is a water quality first, which isn't just a risk averse, don't touch anything. How do we actually engage with the teams around their competency, their training, you know, the tools and capabilities they've had to really minimise the impact that they have on the network overall? And then the top outcome on there, this system is designed to accommodate full range of demand scenarios and altitudes, really links onto this kind of final slide, which is a question that is currently out for tender at the moment as a project. So some of the room may have seen this already. As a big question team, we reflected a little while ago and we said we've got great coverage at the moment, great understanding of two extremes. So water resources management planning, we've all got a framework that we work to. We've got a great supply chain that we call upon to support with delivering those water resource management plans on a cyclical basis. And at a shorter timescale, we've got phenomenal understanding around our modelling capability, hydraulic models, water quality models, etc. But it felt like there was a bit of a gap in between. So what we said was actually, how do we fill that gap? But firstly, is there a need to fill that gap? So we ran a series of workshops looking at root cause, looking at you know, different people's approach to things like tankering, so alternative supply vehicles. So you can see one of our ASVs at the top there. At the moment, there isn't consistency across the sector for that. Now, part of that is because we haven't necessarily got a framework to assess the benefits of those different opportunities, what works, what doesn't work. So really what this project is trying to do is look at, right, how do we balance things here? I've used that word a few times while talking for the last 10, 15 minutes or so. How do we strike a balance where we've got, customers' needs at heart, but we've also got a really clear view on those long-term challenges, the hurdles we're going to have to jump, that hopefully we're not going to fall over and get wet in. So this project is really then looking at, right, how do we establish a consistent framework where when we're having conversations with the regulator, and that could be the economic regulator, that could be the DWI, it could equally be the Environment Agency, that we're really clear on what our optimal long-term approach is for investment and how that relates to our short-term interventions and plans that we've got. Adaptive planning is here to stay. I say to a lot of people at the moment, I think in certain parts for PR24, adaptive planning feels like it's been forced on us. We've been told it's the right thing to do. It is the right thing to do, and that's one of the things we've really got to focus on going forward. So I think that's really all I wanted to say. So my kind of plea for everybody in this room is, if some of the stuff that I've talked about today is important to you, and that might be you individually, it might be for your company, for your business, let me know. Let Joe and Joe Parker know, because this is all part of the kind of one voice journey we need to be going forward. Jez has spent some time over the last few weeks and months going on a tour around the country, and not just because he fancied a tour around the country, but to actually speak to people about leakage, what it means in terms of leakage route map. And again, the feedback from those sessions is, yeah, this is important, we need to talk about that. That's great. We need to make sure we're coming together as one voice through the leakage route map activity, through that MEND work package, so we can really kind of establish what that looks like. It's not a United Utilities view, it's not an UCWA view, this is a water sector view. And I'll leave it there. Thank you very much. So I presume we've got some time for questions. Yeah. Do you want to just open that up for me? And then, yeah.
Hi there, thanks for that. Axel Rendall, Thames Water. You talked about mains replacement as a MEND activity on the PALM framework. What are your thoughts on it as a preventative activity, and how does that link into leakage and not just the act of mains replacement potentially causing a supply interruption, but also preventing future ones?
Yeah, absolutely. I think we've sort of seen it that they're inextricably linked, I think is probably the way we'd say prevent and MEND. So I think, certainly under the leakage route map, for now we've kind of put that under the MEND, but equally, there's a view of the more mains renewal can do, how does that drive down your active maintenance, your in-pipe repairs that we're going to have to do. One of the things we're looking at the moment is there an opportunity that we move to kind of tactical repairs, tactical rehab. We've probably got quite a patchwork network at the moment, let's be honest. Now with patchwork there becomes lots of potential modes of failure. So actually, again, going forward, there'll be a strategic decision on mains rehab, but then there'll equally be places where we go, well, we've been back to that area 15 times in the last 5 years. Now's the time that we need to actually just do a tactical replacement of that rather than waiting for it to go again. So yeah, absolutely agree. So I think probably for the leakage route map, I think it fits quite nicely for that kind of asset maintenance, the M component, but I would not lose sight of that being incredibly important for the P, the prevent element of the PALM model. Okay. So one of the questions on here then is, do you think the literature for mains renewal should be directed to the customer or to the consumer? And do you believe there would be a shift in opposition to the work? I think there's lots of technical components to the literature. I think from a customer perspective, and probably linked back to some of the points that Joe flashed up earlier, from a customer perspective, their real interest is, what does it mean for me? What are the outcomes that this is going to drive? If it's going to mean short-term interruption for the benefit of less disruption going forward. I know I've got someone in my team who on their road they have an asbestos cement pipe that has gone 6 or 7 times, but we've not yet replaced it. Well, now's our time to replace it. And that's the benefit and the outcome there is both a leakage benefit, it's a reactive maintenance, improved position, but actually from a customer perspective, we're not having to turn up on a regular basis. So I think there is lots of literature on mains renewal that I think customers may have interest in, but I think primarily for me it's the outcomes that mains renewal is going to deliver that is going to be a really key area of focus for them. Any other questions in the room? If not, I'll have a quick read through here. No? I like this because I can choose which questions I want to answer. So we've got a question then, how we align and measure holistic benefits delivered for different solutions, that short-term or long-term assessment. It's a really good question, and actually one that kind of links back to, I think, that technological and data challenge. So there are lots of products, and I'll probably look at a few people around the room, lots of products in the market that can absolutely do that for the sector at the moment, in terms of multivariate criteria and looking at the optimization of the outcomes. But equally, there's some sort of fairly simple decisions that we can make. One of the things we're certainly trying to do at United Utilities is, rather than necessarily just jumping to an all singing, all dancing system, is just taking stock of what we already know about the asset base. What's the burst history? What's the material type? What's our understanding of that particular cohort and its likelihood to burst and to fail? And making some decision on that. That's, for me, is the kind of low-hanging fruit. As we go forward, we are going to have to get cleverer in terms of where we target. We're also going to have to sort of balance off what type of solutions we want to deliver based on what we know about the asset base. But there's a real challenge for all water companies. I think it's a challenge that Ofwat have given us as well, of really, get on top of your data. Be really clear in terms of, your GIS data, the location of pipes, condition, age, etc., etc. Only once you've got that fundamental baseline, I think, can you properly optimise the actual delivery of any kind of planned programme going forward. I don't know how much time I've got for this, by the way, so one more? One more? Yep.
Michael Wilmot, Severn Trent Water. Just wondering, this 8-hour interruption, or that customers are happy with, did they say what time of day? Do they want it over the night? Do they want it over the weekend? Could you give us any details on that?
Yeah, so we asked exactly that question, actually, just to kind of get a feel for, was there a preference. There was pretty split opinion, really. Some of that, I think, and there's an area for us in terms of re-asking that question. We had originally asked them that question sort of middle of 2021. And I think a lot of people were still kind of feeling the effects of COVID in terms of their ways of working, whether they were working at home, whether they're in the office. So actually one of the things we've said is, going forward, actually we're going to need to do that bespoke research. It's not just about, we've got some research we did 3 years ago which says this is fine. We will need to go to those areas we're planning to deliver mains renewal and ask the question to customers. Because within those areas there may be customers who have a very different view to the kind of regional view that we've collated as part of the kind of corporate research that we've done. And that's where it kind of aligns to the priority services point. Actually understanding the demographic of the customers in those areas will really inform what we do, when we do it, how we do it. There's also a kind of question around the solution, the type we deliver. One of the things we asked of them was, what is the impact of different equipment, etc., in terms of disrupting your day? So if we've got multiple generators on site, what's the optimal time of day for that? So actually it might be good for us to do it overnight, but do you really want a series of generators, etc., outside your bedroom window when you're trying to sleep? So I think the sort of short answer for that is that it will need to be, dependent and informed by research we deliver with customers, informed by where we want to target these mains replacement programmes. Okay, brilliant. We'll leave it there. Thank you very much.
Thanks to Sam and John for that presentation. From my own perspective, I think we have to think about on a wider basis, what customers will think in an industry that is under pressure and criticism from so many quarters, to moving from a 3-hour standard to an 8-hour standard. I know you've got the best reasons at the heart of all of that, but we've got to get that message across somehow, and we're not great at that. So, thanks to Sam and John, great session. Now we're on to the Ofwat Innovation Fund projects, of which we have 3. So we're going to start with somebody who needs no introduction from me, but I will introduce him anyway. This is Jez Heath, who's the Innovation Manager from SES Water, to talk to us about the Universal Access Point for Water. Jez.
Thanks, Bob. Lovely to be here. Some of you will hear I'm slightly husky. I've done 40 hours of talking, and goodness knows how much driving, 3,000 miles of driving, doing my Leakage road trip, which has been amazing. You'll hear more about that tomorrow, because I'm now going to talk about the Universal Access Point for Water. Now, Some of you will remember the kiddies film, animated movie, Robots. 2005 it was released, and it was basically about inventing, which I loved. It was about innovation and all sorts of things like that. And one of the characters was this great big robot called Big Weld. Yeah? And Big Weld had a phrase: see a need, fill a need. See a need, fill a need. That's my job. I'm an innovations manager. My job is to know what the problems are, and then when Daniel and his team come along and go, we're trying to solve this, I'm meant to be the person that comes up with the solutions. Look, I've been doing leakage for some years now, and one of the things I've become very aware of is a need. And that need is how we carry out inspection work on our pipes. There's loads of stuff that we're currently doing that we're struggling to do with because we don't understand what's going on inside our pipes. And it's really hard getting something in there. And there's loads of stuff that I see coming over the horizon that needs us to be able to get into the pipes. One of the things we've talked about is mend. How do we get inside pipes and mend them from inside? So it's like, hang on, wait a minute, there's a real need here. So of course, you see a need, you try and fill a need. And that's the universal access point for water. So just a quick explanation on that. This is an Ofwat funded project. Ofwat slapped £200 million on the table. I'd like to say it all went on this, but it doesn't. Okay, that's distributed out through all the different water companies, and you apply in and say, look, we'd like to have some of that money in order to solve this problem. And what I was looking at was this: leak inspection and location. There's loads of devices out there, either current or under development, that we need to get access into that pressurised water pipe. You know, tethered, untethered leak location arrays, pipe inspection, water quality, in-pipe fibre optics, internal mains repair sealants, and yeah, autonomous robots. The issue that we got is, you think about all the fittings that we have. Every fitting we have is designed either for keeping the water in the pipe or for letting water out of a pipe. There is nothing designed for putting devices into pipes. So we said, okay, can we do something about that? You know, currently, we say, you know, you do it through a hydrant. And the thing is, everybody goes, that's all right, we've got loads of hydrants, just stick it through a hydrant. The issue with going in through hydrants are manifold. You speak to the suppliers who have to do this, and they will tell you the number of times they turn up. And they're told it's a through-bore hydrant, it's easy, you can get on it, and there's not any issues, and then they turn up, and they can't get the camera in. It's not a through-bore hydrant, there's all sorts of issues. And of course, the other issue is, all of your devices are being constrained to go through a tiny entrance point. So every camera, every array, every sensor that we put down through a hydrant has been naturally constrained because it's got to fit through that, and it's got to be able to navigate the bends and turns inside a hydrant. Yeah, of course we could do under pressure tees. Simple solution, cut in an under pressure tee, we'll do it through there. Talk with the guys that actually have to do this, and they kind of start waving their hands and looking very pale, because as soon as you do an under pressure tee, you've got a lovely sharp edge on the inside of your pipe there, beautifully snags up all of your cables and everything else like that, and causes you no end of problems. Well, that's okay, we'll all come up with our own bespoke solutions. Sahara, come up with your own solution, but the trouble is that's designed for their solution, it's not designed for everybody. So we kind of looked at this and said, okay, we need to have something that we can install either when it's laid, when the main is laid, or subsequently cut into a pipe. Yeah, it's available for a range of materials and diameters. It's a standard entry, but it fits 3-inch up to 12-inch. Okay, it's a single standard entry port. And it will allow devices either tethered or free swimming. You can stick them in and it'll go into a pressurised water pipe fine. DWI are looking at this. They're obviously slightly concerned with what I'm doing and going, you're putting stuff in pipes. I'm going, we're putting stuff in pipes anyway. Let's actually do something, let's actually use something that's designed to do it rather than something we've just adapted. And we would have safety features in there that actually stop someone unauthorised from doing that, as opposed to a hydrant, which anybody can go along to. And then have connection points as well. So the interesting thing about this is I'm running this project in a very similar way in which I would do an innovation project at SES Water, my own company, which is rather than apply for all the money at the beginning, go to my directors and go, I need this much cash in order to develop this and build prototypes, because the first question they're going to say is, well, is there actually a need? Yeah? What's the design look like? So in fact, that's what I'm doing first, and that's all I've applied for in terms of the funding. We're literally just doing the design piece and coming up with, okay, this is what it looks like. And then the second really interesting thing I'm doing is looking at the IP, because generally the intellectual property associated with this is owned by someone. And they license it out and say, yeah, you can use my design, but you pay me some money every time. And we said, nope, not doing that. You know, when Volvo invented the seat belt, they basically said, this is for the good of the world, and they put no IP on the seat belt because they said it's for the benefit of everybody. Interesting enough, karaoke machines have no IP as well. Not that that's relevant to this one, but this is open innovation. Okay, what we're doing here is there's no IP associated with it, and therefore, once we've done this piece of design work, any of you suppliers out there will be able to pick this up and run with it. And when we're doing this, we're not just doing the design work, we're going to be going beyond that and looking actually at all of the economic values. We're going to be looking at how much we think it will cost to produce. We're doing all of that side as well. So it's a complete piece of work for anybody out there to pick up and run with. What's the advantages? Standardized dimensions. Okay, means that devices that currently you can't get through a hydrant, you could use. We get better sensors, better data storage, better battery capability. You can gather opportunistic data. One of the examples I've been saying and talking about is going, okay, you have a burst main. Okay, so what you want to know is the whole main rotten? You'd love to know what it's like, 150 meters in either direction, but you know what? Supply interruptions, 3 hours, you've got to get it on as fast as you possibly can, and your guys are standing there ready with their torque wrenches, ready to bolt it up as fast as they possibly can. There's no hope you're going to get a camera or any kind of sensor device up there. So drop an EUAP. Drop an EUAP, get it bolted up with the rest of the kit, turn the main back on, and suddenly you've got a point where we can put the camera both ways up 150 meters and actually have a look at the pipe and work out what condition it's in. You've got a new estate being built. It's going to be laid in plastic, which we all love because, hey, plastic never leaks. As we all know, it does. And we have issues on those plastic mains. So you're going to say to your developers, do you know what? You're going to cut in UAPs here, 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 and here, because in 4 or 5 years' time, when we're looking for leaks on your network, I want to have a point on the network where I can stick a device down it really easily and just run it through this network and have a look and find out where the leakage is coming from. There's a number of partners involved in that. There they are. So you've got 5 water companies in there. WRC are involved as well, doing loads of work on that one. University of Sheffield as well. They run the Pipebots program. This is solving one of their big issues about how do we get robots into our water pipes. So I'm working with them on that, and then Fluid Consulting as well, who are managing the project with me. So where have we got to? Well, we've got 4 work packages there, and the first one is about vision requirements and specification, and we've had our first meetings on that. Everybody gathered together and started going through. We ran it as a virtual session as well, so we did one that everybody could come to in London, and then we did the virtual session. Everybody could feed into that one as well, and we said, okay, why do we need a UAP? What are the current limitations? What will it enable? Loads of post-its, you know what these things are like. Loads of coffee, post-its and cake. And we started to come up with, okay, what's the must, should, could, and won't. I haven't put all of them up on there, but this is what we started to come up with. So we've now got an understanding of what this design should look like. So we're at that point at the moment. It's early days still, yeah? We've now got to take that must, should, could, and won't and start to turn that into physical designs. So going back to here, we've got economic assessment, which is ongoing. In June next year, we're going to start looking at the development of these design ideas, and then finally by September, a preferred design, and then next steps going on from there. So, that's basically the project. I think I've won you some time back, haven't I? Yeah, fantastic. I'll do questions in a second, but look, the reason I'm telling you all this is, firstly, this is an Ofwat funded project. You've all paid for it. Every single one of you. Because if you pay your water bill, that's where that Ofwat fund comes from. Okay? So you deserve to know what's going on. So there we go. That's what some of your money has gone towards funding, this understanding. Okay? And secondly, you may want to be involved in it. So as I've gone through this, you're thinking, yeah, my company would want to really be involved in that project. fantastic. Come and see me, catch me, I'm at the conference, and grab me and say, yeah, we'd love to be involved in this. When's the next workshops? Can we see the outputs? Because although I have 8 companies working on this piece of work is open to everybody to join. Those workshops are not just for those 8 companies, they're for everybody that wants to be involved in this project and sees advantages, maybe just for their company. They're going, yeah, we'll be wanting to pick that up, or we want to redesign our sensors so they can use this. So please be in contact, love to have you involved and engaged on that. I'm going to stop there, and you're thinking, fantastic, Jez doing a short talk for once. I'm going to stop there, but I will take any questions first. I need to jump back here, don't I, to the tablet? I don't.
You stay there, mate, don't worry.
I'll stand here.
We've got the... So any questions in the room to start with? I'll just put that over there. Is that really
That's mine.
cold water that you bought in a shop?
Stop it. I've got my throat's going. I literally had to get some. Okay, I'm so
Disappointing,
sorry.
Jez, disappointing.
Oh, man.
Right.
In front of a CEO as well.
Questions in the room? Ooh.
That's good. Just leave it, mate. It's fine.
Right. If you're putting in after a repair, could a TBH, I guess that's one of those, not just be installed? Does the solution already exist?
So I did do quite a bit of horizon scanning, looking around for various ways of doing this. And in terms of cutting something in, and we've been speaking with all of the kind of like the companies that do certainly devices going down, and again people are coming back going, no, it doesn't exist. There was a German solution that's working on rising mains, and in fact I met them this week, last week, and was chatting away with them, but it's not really suitable for what we're trying to do. The big issue that we've got is the fact that this is on pressurized water, and we need to have bends and radiuses on the inside for when you're putting cameras in so they can go both ways and things like that. So it is quite specific to what we're trying to do. Interesting enough, the people doing the sewerage side are now really interested in what we're doing because they think they can adapt our work to what they're doing.
So is a TBH, is that like a hatchbox type thing in sewerage, is it? Speaking as a...
Through-bore hydrant.
Through-bore hydrant, right.
Yeah,
okay.
the problem with through-bore hydrants, again, let me just go back to that. Yes, absolutely, you could just cut in a through-bore hydrant and just do it that way. But firstly, you are constraining every device that you put through that thing down to that entry point. Okay? And that's a limitation. As soon as you're doing that, you're saying everything has to go through that. And secondly, when you talk with the through-bore hydrant people, they will tell you the nightmare is he's trying to go both directions. Okay? Really, really hard to get that steer on it, and therefore what you tend to do is find it's easy to go one way and not the other. Really what you want to do is when you're doing that cutout, you want to be able to very, very easily jump in the pit and go 150 metres both directions quite easily. And that's part of our design criteria, is that it should be as easy to go both directions.
So in terms of installation, am I right in thinking that this is opportunistic? Well, it can be, I suppose it can be, you can do it in a planned way and an opportunistic way.
You can use it both. So one of the groups I've been talking to about it is the people that want to do relining works. Now, I came in and was doing relining works when I first joined this industry, and effectively you're cutting out sections going up the main, okay? And then you reline in between those sections. One of the ways of doing this, and the relining guys are really interested in this approach, is the ability to send your crew on in front of you and cut in UAPs going down the line, and then you line through the UAPs. Now, there's quite a few technical bits on that because you've got to get things like rigs in and things like that through that point, and that's why we're in discussion with them at the moment. But yeah, they're really interested in that ability to actually pre-plan your works and cut those all in. Again, imagine for a supplier, if you want to do trunk main surveys, what you could then be doing is, okay, look, there's nothing there, so we pre-cut this in, get that all there, you know those are going to work, so when your supplier turns up, he's not standing around for 3 hours, yeah, and you guys going, oh, maybe we'll try the next one down, because he knows if there's a UAP, he knows it's going to work there.
But I think what's subliminal in what you're saying is that this is a cut-out solution, not an under-pressure solution.
No, I'd like to be able to do it under pressure as well, and part of the design brief is under pressure, because trunk mains and everything like that, you need to be able to do it.
Okay.
So I see it absolutely as both, and part of the design brief is we should be able to do this under pressure.
Okay, so another question from the pad here. When is it going to be ready?
Love it. That's really nice, because that's suppliers going, please, need this, last week. When's it going to be ready? So we're going to finish the design work, as you can see on our program, is going to be September 24. To be absolutely honest, it really depends on who picks it up and when. Now, I'm willing to go back to Ofwat and say, okay, if I've done that and nobody does, and we need to do more work for it to be picked up, to start to take those designs and turn them into prototypes. But to be absolutely honest, I'd be really happy if a supplier just steps in and goes, we just take that, Jez, we just use that design work, and we're just going to run with that one, in which case, you know, it's kind of, this is going to be standard metalwork stuff. It's not going to be weird stuff. So it should be, they could turn it around quite quickly, I hope.
Soon, yeah. Okay. Right, is anybody, oh, there's a question from the floor over there. He wanted, he put his hand up very sharply as I looked up.
Hi, Jez, Dan Lawrence from Seven Trent Water.
Hey.
Yeah, Dan Lawrence, Seven Trent Water. How will you make sure we can still use the sort of equipment and innovation that we've currently got, so it won't make that defunct and obviously cost a lot of money?
Yeah. So you're always still going to have hydrants. Okay, hydrants are always going to be there. So let's go back to that brand new estate where you're going, we're going to cut in UAPs. You're still going to have hydrants at your ends because you'll want them there. The fire brigade will need them there, okay? And you'll want washout points. And what we're not doing is with the UAP is making it into a washout point. It's completely separate from that. We haven't designed it to do that. So you're always going to have hydrants. What it does is it gives you more choice. So effectively you'll be going, okay, in this situation, there's no UAP, there is a hydrant, we'll use that device and we may get 70% of the time we may actually be able to get the camera through and we get some pictures from it, but you know what, if we're going into a 6, it's going to be harder because it's a bigger main type approach. Therefore, the UAP will be supplementary to that. It's kind of like, is there a hydrant? Yeah, we can use that. Is there a UAP? Whoopee! We can go for the bigger cameras. Okay, so that's how I see it working.
Any further questions from the floor? So, when I was a young man, which was a long time ago,
not that long,
you and I worked in neighbouring water companies, you after me of course, and I discovered that your water company had got themselves a camera,
yeah,
you know, to put inside pipes, and I also discovered that they weren't really using it. So I got this camera in, I did all these surveys, you know, when we were doing first mains, when it was cut out, we'd go that way, we'd go that way. Great, got all these videos, stacked them up into the library, only for a colleague from WRC to come along and say, well, actually, there's no conventional technology or kind of approach for renovation that brings videos into play. So is that now changed?
Yeah, completely. So I was at a conference, so last week I was at the UK STT, which is the United Kingdom Society for Trenchless Technology. You'll be pleased to know they exist. Okay, and they were showing some of the latest stuff that's coming out in terms of sewer rehab and effectively going, yeah, it's all done by AI. So previously, like you, I can remember having to sit and watch videos of pipe. It was the most exciting thing you've ever seen in your life, a camera going up a pipe slowly. These days, what they do is they put the whole thing on AI. So they just upload that video and the AI scans down and goes, right, I can tell what's going on. Interesting enough, the Americans have got some really good tech at the moment coming through because they're doing loads of rehab work. They need to know the condition of that pipe before they rehab it. So some of the American companies won't actually choose their methodology until they've turned up, drained the main down, and then they'll do a probe down that pipe. Yeah, they'll actually do a research of the condition of that and then and only then decide which technique they're actually going to use to rehab that pipe. So yeah, the technology's moved on massively from our day. Thank goodness.
I'm talking about quite a long time ago as well. But I have to say, probably 50% of the time, the pipes were so tubercled that you even couldn't get the camera in for that reason. So that's another consideration, isn't it, with these access points?
Yeah, absolutely, and getting those in as well. I mean, interesting, so a lot of the tuberculation would have gone under the Section 19 undertakings, though, because we kind of tried to get rid of it for them. Sorry.
Okay, time for one more last question. Okay, I think we'll close it there. Please show your appreciation to Jez. Thanks, Jez. Okay, so now I'd like to welcome two speakers, and one is in the room and one is in Australia. So Michael Purvis, who's the Managing Director of Seal Water, and William Smith, the Technical Director of Seal Water, and they're going to talk about the active pulse leak detection and active sonar. And there on the screen we have Michael. No, William, sorry.
Hello.
Give him a round of applause. He's all the way in Australia.
Can I have my slides now? I'll bring in William later on at the end for questions. As mentioned, my name's Michael and I'm the Managing Director of Seal Water Tech. And we've been fortunate to be selected in the finalists for the Ofwat Water Discovery Challenge. This is a funding program for smaller tech companies on a lower TRL. Along with William, which you've just seen, coming from Australia, it's very early in the morning there, or it's very late at night, I'm not sure, but it's probably late at night because he's a night owl. What we want to introduce to you is a new approach to leak detection, active sonar. This technology, we can detect leaks kilometres away in all pipe materials, plastic, is non-disruptive and non-intrusive to pipe networks. On my slides. So, just showing you quickly here, this is one of our units. And this is just connected directly onto a fire hydrant going through a faucet valve. This was taken at Brands Hatch in Kent. So the second one. I won't dwell on this too much, and particularly this forum, but water loss through leakage is a massive problem worldwide. Here in England and Wales, and overseen by Ofwat, water loss through leakage has been driven down significantly. However, we're now approaching a scenario where all the low-hanging fruit at easy to find leaks have now been found and repaired. And this plateauing is partly due to the limitations of current best technologies out there. What we can consider one of the best technologies is correlating acoustic sensors. However, due to fundamental physics of sound in water, these are limited and always will be limited to 200 to 300 metres in range. So, to break this low-hanging fruit scenario, we need a step change improvement in in technology. This is where Seal's long-range solution can play a significant role in finding those hard-to-get leaks. This is particularly useful in trunk mains where you have limited access points. If you've got, say, a 5-kilometre pipe and you've only got access points every kilometre or 500 metres, to correlate that, you would need to get down to the pipe, put access points along there. We can do this from either end or from the centre. Plastic pipes, it works equally well in plastic pipes. Correlators are further reduced in plastic. And it's ideal for critical infrastructure where you don't want to be touching the pipe. I heard people talking about the risk of access in the pipe. Some infrastructure, you don't want to be touching it, you just want to be monitoring it. As long as there's some access points on there, we can get in there. So what do we do? What do we do differently? The crux of our innovation is a new signal transmission technology that does not attenuate, unlike sound, and where we get the leaks and other pipe features to talk back to us. How do we do this? What we do, we generate a very small but intense pulse. We then inject this into the pipe, and this pipe travels down the pipe within the water. Someone touching this? This pulse travels down the pipe in the water and then interacts with points of interest. And these interactions we can detect, leaks being one of them. And then from this, we can calculate the distances out to these points of interest. We can also pick up T's and elbows. Right, this is one of our data sets. On here, there is 7.5 kilometres of pipe data taken from one test at one location. I'll start from the left. Oh, what is going on here? Take that with me. On the left here, this is your background noise. On the far right, this is where we've injected the signal into the pipe. Initially, we get a lot of noise, a lot of background noise, but this quickly dies down. And as you move along, you can see negative pressure events all along here, and these are far greater than the background noise. What I'll show you on the next slide is what these line up to. So going from left to right, that is distance from the test point, and this is 7.5 kilometres. And now at this range here, we're still picking up pipe features. Drilling into the data, far left again, that's where we've initiated the test, quickly settles down. We have a big negative pressure point here. That lines up with a road intersection and a pipe intersection. As we further go across to the right, we have a series of negative pressure events. These, I will show you later, lined up with 25mm T sections coming off this pipe. Drilling in again. These are same negative pressure events, and this one here has a classic leak signature. So that's a classic leak signature. This is what we're looking for. This is our business. We then went out to this site, located the leak, and then repaired. Right, get that back. What we then do is we scale we scale our reading onto a GIS map, and up the top left here, where the circle is, I'm not sure what's going on here, where the circle is, that's where we did the test. The signal went to the left and to the right, then the signal came down the page, and then this is the road intersection here, and then some of the signal went left and right from there. And here is a series of small hobby farms, or small hobby farms, and this is where we got those series of pipe fittings. Like I said, we went out to the site. The leak signature was tied into one of those fittings. So where's the value in all this? Firstly, it's long range. We can survey kilometre sections of pipe at a time. Sound methods, only a few hundred metres at a time, assuming you can get access to it. To monitor or survey a DMA, only a few units are required, or a few tests are required. It's non-destructive and non-intrusive. As you can see with the first slide, we connect directly onto a fire hydrant. So it's ideal for monitoring critical infrastructure. So what have we been doing since we've got the first part of the grant money? We said to Ofwat we'll be spending the money on software, hardware, and doing proof of concept trials in the UK. Since the grant, we've been working with Andrew Mackenzie from Water Leak Location Services and Portsmouth Water, Matt Burrows. So we've gone down there, we've had a series of pipes where we sort of test, a series of pipes where we're testing. We've done a test on a larger diameter pipe. The units we've got, our prototype units, are only designed to 50 to 80 mil. We did this on a larger diameter pipe. This pipe was previously correlated. There was access points every 500 metres, but there was a leak signature picked up with correlation. We could verify where the leak was, but to be honest, because of our signal strength, the size of our unit, it's not designed for that size. We could pick it up only because we were looking in that area. So from that, we've now, in Australia, we're building a larger unit up to 500 mil. That will be tested and run through in Australia before we bring it out to the UK. We've also done another trial down in Portsmouth where we had a 3.2 kilometre section of pipe. We went to one point, the first trials, we went to the first point on the test. It was too noisy, so we went to the other end of the pipe. We picked up a leak signature. This was later verified by satellite to say there's a leak in this area, but again, that hasn't been dug. We've retested it again, and we're just going through the data there to try to locate where that leak is. We're testing it from both ends. Previously, we only tested it from one. We did a signal strength test. We got Andrew and Carl from Portsmouth Water. We put them in a field 1.2 kilometres away from the test point. We sent a signal down there, and they picked that up 1.2 kilometres away from the test point. That could never happen with sound technology. Another thing we're working on in the project, we're trying to find out when we start the test. I know this sounds pretty stupid, but when we actually press the button to do the test, there's a few little things go on. And you saw that picture, had all that noise in there. We need to know when the test was started. I had a part sent out a month ago. Unfortunately, it got damaged in transit. It didn't work. I was in Australia, just got back from Australia yesterday. I've got a new part, so we can then do that test, so we know when the test starts. And the reason this is important, we get a long trace of data, which we can scale. We need datum points in that to know when we start the test. If you've got a known leak in the system, we can use that as a datum point. Or if you've got a known fitting, we can use that as a point. But one of the key things we need to find out when we actually do start the test. Data processing, Andrew can attest, is very slow. At the moment, we've got 1 million readings we go through. We do this on an Excel sheet. Takes a lot of time. So in Australia, we're developing, with funding, we're developing software which will be feature recognition. So we just run it through the software so you can pick out a leak, and ranging. So once we know when we start the test, so we can then just range it. So hopefully at the end of this year, early next year, we can just go to a pipe and say, right, you've got a leak 2.3 kilometres away, go the other side of that, do another test, and then at least you're going to be able to get the other guys in there within 10 metres, 5 metres of where that leak is. Separate to the Ofwat funding, I'm good friends with the estate manager at Brands Hatch, the motor racing circuit in Kent, so I'm working with him. He's got some leakage problems, but big problem he's got, he doesn't know where his pipes go. So we picked up all his leak signatures, and the guy who put the pipes in, he's retired, and we don't know where the pipes go. So summing up, the physics of this is now established, so we can consistently pick up leaks, tight pipe fittings at distance. It is a new science, or the better say it's a combination of old sciences, and we're still in the early stage of understanding what we see in these readings. In the last 3 years, we've been getting all our patents in place, so we've got a very strong patent with 23 claims. And just an interesting thing with the patents, when we did the search and reporting phase, the South Korean Navy had something not similar, but it could have been a problem, but it wasn't. But they were looking for North Koreans, not leaks. Right. The team behind all this, Dr. Duncan Hewell-Evans, he's the original inventor of the concept. He's actually dual PhD, but he's from Staffordshire, immigrated to Australia, along with co-inventors William Smith, which you see in a sec, and Ying Lee. James Bess, he does our data processing. He's old-fashioned engineer, and I won't give away his age, but he was involved with the Sizewell and Dungeness power stations when they were doing the commissioning of the water treatment plants on them. Dr. Leonard Casson from the University of Pittsburgh, myself and Dorothy Nashe, and with the Ofwat funding we get 2 mentors, Danny from Yorkshire Water and Jeremy from SES. Sorry. So just finishing off, if we want to make water more efficient in England and Wales, we still need to deal with leaks. We've got rid of the easy ones. We now need a technology to find the harder to get ones. This technology will do this to help build more sustainable networks for the future. Thank you. And thank you for Ofwat. Thank you for Jez and Danny from Ofwat, Portsmouth Water, and Andrew McKenzie. Right. We need to answer a few questions. Well, William's going to answer some, and what he can't, I will. Okay. So you brought William in.
In the middle over there. Can you get the sound on, please?
Hi there, Tanya from Dayworth. I was just wondering what happens if the leakage event is close to where you initiate the sound? Because it appeared on your graph that got really noisy. Is that an issue, or is it something that you can sort of get out of the data?
Have you got that, William?
So the initial returns, they overwhelm the amplifier and it clips top to bottom. We sometimes can see a leak in that zone, but we prefer to be at least 500 metres away from a leak. So we call that first part our blind zone. We're sort of semi-blind. Once the spectrum settles down, we get a very good signal to noise ratio out the rest of the distance to 7.5 kilometres. So the longest range we've detected a leak to date was about 3.5 kilometres. Shortest range was in the blind zone at about 126 metres, but that was an unusual circumstance.
You can detect the leaks in it, but it's a lot harder, as you can understand.
Any more questions in the room? Ooh, that was an echo there, all the way to Australia. Okay, let's go on the Slido then. Let's have a look. Will it find new leaks as they form, or just existing leaks?
As they form.
Yeah.
We need a leak to find it, so it needs to be leaking. But it has the potential. Am I echoing too much? I'll stand over it. It has the potential to find different size leaks. In Australia, William he's got 300 metres of pipe going around his house, which is great for the neighbours. But we can tell the difference between a vertical leak and a horizontal leak. But it's sort of, we need to know a lot more about leaks before we can. We need to build a database.
So it's designed as a survey tool. You set it up.
Yeah.
You do your pulsing and then you go somewhere else after you found those leaks, as opposed to having something that's constantly pulsing your network.
Oh no, you can use it for monitoring.
You could use it for monitoring.
So you could set it up, and if you're getting the same trace every time, then you know nothing's changed. But then if you get something happening, then we'll pick something happening up in that pipe.
So how do you determine what a typical leakage peak looked like? I'm not sure that we saw any. We didn't point out any leaks on those graphs. And you showed where the junction was and all the orchards and things.
Yeah, a leak signature has got certain characteristics which we probably don't want to really go into, but it's got certain...
you can tell them.
Yeah, they're formed in a way which is the same way the signal's generated, and they can come back that far, but it's a certain characteristic and shape what we're looking for.
Okay. What's the leak location accuracy?
Depends on how accurate your GIS maps are.
Okay. If you have an accurate GIS, how accurate is it?
Well, with Andrew, we verified a leak with their correlation to within 20 centimetres.
Wow.
But it depends on datum points when we start. This is why these datum points are important to us. But theoretically, you can get it down to centimetres.
Okay.
But if you've got accurate maps, accurate features, then we can get it very close. If you haven't, then it'll be to a couple of metres.
All right. Okay, any remaining final questions in the room? Yes, we have one in the middle over here. Microphone's on its way, just behind you. No, it's not a pantomime.
Hello, Dilraj Dillon, Crowd Consulting. How long does it take to deploy the kit?
Say again?
How long does it take to deploy the kit?
How long does it take to deploy it, yeah? How long does it take you to set it all up, basically?
10, 15 minutes. Yeah, you just clip it straight onto a hydrant, pressurise it, play with your data logger, and away you go. So you could survey a 5 kilometre pipe in a day easily. Okay, any other burning questions from the room? Yeah, we have one down the front here. The microphone's on its way, please wait. We want to hear your dulcet tones.
No, I'm just wondering if the signal is proportional to the leak volume.
Yes and no. It is, but also to the shape of what we're looking for and the size of the shape. So, yes, the answer is yes.
Because obviously in the industry we want to find leaks, but we want to find leaks that are significant and repair them.
Yeah. As like I said, we can pick up leaks, but what we don't understand yet is, say if you've got the signal, say 2 kilometres away, we haven't got the data yet to say this signal is related to this leak. This is why we need to do a lot of testing on pipe. So we're sort of looking for utilities to say, right, we've got a leak here. Before you fix it, we want to come and ping it from 1 kilometre away, 2 kilometres away, over this side, over that side. So then we get, you tell us how big that leak was, and then the next time we can say, oh, that just gives an indication. So it's a new science for this, and we need to develop the data bank behind that to size leaks and see what we're seeing.
Okay. All right, well, we'll close the question and answer session there. Thank you very much, Michael, and to William in Australia. Amazing quality of sound and everything all the way from Australia, but thank you very much for a fascinating session.
Oh, thank you.
So we're into the last lap between now and some networking and a glass of something cold in the bar. So now I'd like to welcome Stuart Trow, who is a consultant at HWM in Venio, and he is one of the lead partners on the Managing Background Leakage project, which is an Innovation Fund project. Over to you, Stuart.
Thanks, Bob. Can I start by wishing everyone a happy World Water Loss Day? A couple of years ago, the National Water Association thought it would be a good idea to have an annual day dedicated to water loss, and this year it just happens to be on the same day. So 4th of December every year is World Water Loss Day. I thought I'd mention that. Managing background leakage. This is an update of a project which we've been running through the course of 2023. I want to give a bit of background, give a progress status report, and then show some results. So the first thing is the Water UK route map. We've heard a bit about that this afternoon. The definition of background leakage in the route map is up here. It's a level of leakage which cannot be reduced further using current detection technology. It can be altered by replacing pipes in the network, theoretically, and also by reducing pressure in the network, definitely. And it can also change due to new technological innovations that make detection more effective, such as the one that we've just heard about. So this project came about at the start of 2021, when shortly after Water UK had sort of committed to this 50% reduction in leakage by 2050. And I put this graph together. It was a bit of guesswork at the time, but what I was trying to show was that how can you reduce leakage by 50% if we think, as a guesstimate, 50% of that leakage is what we call background leakage? And then on top of that, we've got leakage from reported bursts. Everybody has a burst that's running that they know about, which is awaiting repair. And then you have trunk main leakage on top of that. So the background leakage, we really refer to background leakage in DMAs. So there's only this bit at the top here, probably 25% of the leakage, which you're controlling by new technology to become aware of leaks quicker and find them quicker and repair them quicker. So really the challenge is, what do we do about this background leakage and how well do we understand it? So some terminology. MAL is the minimum achieved level of leakage, and that's what we focused on in this project. It's the historic minimum achieved level of leakage in the DMA from night flow measurements. We actually had a challenge of how do you define that though? And we had to come up with a method of estimating it. And then MABLE, the minimum achievable level of leakage, that's based on the theoretical minimum achievable level, based on infrastructure in good condition from the managing leakage reports. Essentially though, the MAL level is the level of leakage you're left with after you've done a normal leak detection sweep through a DMA. And MABLE is based on this table in Managing Leakage 2011 in report 4. It was originally introduced in the managing leakage reports in 1994, and it was defined as the level of leakage from minor leaks, so small leaks from valves, joints, hydrants and so on. It was believed that those leaks would generally be less than 100 litres an hour and not individually identifiable on a DMA flowchart. But the report did say that there could be some undetected leaks in the range of 100 to 500 litres an hour in those DMAs. And we sort of picked up on that and thought, well, how many of those larger leaks are included in the minimum achieved level of leakage in the MAL level? But again, it was expected that leakage level, that MAL level, would reduce over time. But it's 30 years since these reports were produced. Technology's moved on a pace, and yet we're still left with 50% of our leakage being this MAL. We estimated that at the time. So that's the background to the project. Oh, sorry, before that, just to point out that these values were actually heavily weighted towards customer side at the time. The distribution mains is in litres per kilometre per hour, and the service pipes, the com pipe and the supply pipe, are in litres per property per hour. But if you look at a fairly average mains length per property, it is heavily weighted towards the supply pipe rather than the mains. So the project that we have funded by, or largely funded by Ofwat, aims to reduce that, it aims to redefine the detectable limit of leakage. Can we reduce the background leakage or the MAL level by finding some long-running hidden leaks that have evaded leak detection? The project's led by Welsh Water with support from 4 other water companies, the Anglian, Severn Trent, Portsmouth and Affinity. The total value of the project is £3.5 million over 30 months, so it's quite a large project. And HWM and Venio and University of Sheffield are the main contractors. These are the stages that we go through. We select DMAs for survey, usually between 900 and probably between 500 and 900 properties, average about 700. We've got one which we're coming into, which is larger than that. We then install multiple sensors. We create a digital twin or a network model of the DMA. We localize the leaks using that model, and then we have to use the sort of technology that we've been hearing about to pinpoint where those leaks are occurring. So things that we're doing differently, the model that we're producing, we're not grouping the demand to nodes in the network. We're creating an all connections model of the DMA. We're profiling the consumption at 1 minute resolution, largely using our stopwatch temperature loggers, which we've been doing for 8 years now, but also smart meter data where it's available. And so we're modelling the consumption profile for the remainder based on those logs. We're logging as many properties as we can, and then using that data to model the rest of the housing estate. We're fitting pressure loggers to every available hydrant for 15-minute values, but we're also collecting transient data. 100 hertz pressure logging, 24 hours a day, 7 days a week, on 3 to 4 points in each DMA. Now that is an awful lot of data that we're collecting there, and the loggers have been designed specifically for this project. We're also installing acoustic loggers across the whole DMA, and then we're combining the data sets. The little diagram in the bottom left there is this sort of all connections model that the University of Sheffield have produced to collate the data. So where are we up to? If I can take them company by company, the first 2 DMAs in Welsh Water are complete, and the analysis is complete. We then went into Severn Trent. The fieldwork is complete in both urban DMAs. We've got an area of interest in the first DMA that we're following up on, and we're currently processing the data on the second. We've then been into Portsmouth and done their 2 DMAs, and that's just recently been completed, and we're analysing the data. Anglian, we're starting today in the first DMA in Anglian, in an area that's largely smart metered. I think it has 85% coverage of smart metering. And then we're just finalising which 2 DMAs to go into in Affinity in the first part of the year. That will complete the first phase of the field work, and then starting early part of next year, we have to do another 15 DMAs, 3 DMAs for each of those 5 companies, where we scale back the extent of logging to make it more economic or practical. We haven't yet decided exactly how to do that, and we've got a meeting coming up to work out the process. We've had some difficulties. Some of the areas we've been into have proved extremely difficult. This is just one photograph we've had of somebody looking for a stop tap that feeds a property. So we've got long lengths of mains with hidden stop taps. We've got country lanes where the stop taps are in the roads with national speed limits. And again, high speed roads in urban areas that we've been into. Some of these stop taps, we just can't find them at all. Some of them are on joint supplies. Some of them are full of material, debris that we have to clean out. And then in Portsmouth, we have a new problem where we've got modern houses with wall-mounted meter boxes, and our stopwatch system isn't designed for that, so we've had to come up with an alternative for that. And then we've got things like blocks of flats and commercial properties where we've had to find a different way of estimating consumption on those, or leaving that and moving on to a next DMA. As I say, we've got an awful lot of data. One of our biggest challenges over the last year has been to produce a data warehouse and to look at the data flows in that data warehouse. Obviously, I'm not going to go into detail, but we've got the field team, the analysis team, and then University of Sheffield and the water company with data going between those various parties. The first thing we did at the end of 2022, we did a desk study looking at the MAL levels in those 5 water companies. And this report, what we call the Stage A report, is available publicly via that website link. And I think you'll get copies of the slides so you can follow the link. It'll take you to University of Sheffield Figshare site where you can download this report. And it has some interesting data in it. We had to publish all of the data, but we've been allowed to redact some of the individual company data. But what this first table in that report shows is that the total megalitre a day of leakage in those 5 companies is 935 megalitres a day. So that's about 30% of the England and Wales total. So it's a good size sample to go on. The second thing it shows is that 49% of the KPI leakage in those 5 companies is MAL, it's background leakage. So our guess of 50% was pretty accurate. Then we have reported leakage of 5%, unreported leakage of 31%, trunk main leakage of 15%. So that's the average over those 5 companies. So I think it's important when you think of leakage, not to think of leakage as one entity. Where is that leakage occurring? And then also, what type of leakage is it? Which I showed earlier, the iceberg diagram of reported, unreported, and background leakage. And then when we've looked at the distribution of that MAL level, that background leakage across the DMA stock in those companies, we see that there's a wide variation. What we took as the MAL was the 5 percentile value over, I think it was 3 years. Steve will correct me if I'm wrong. And the way we've displayed it here is we've got litres per property per hour and litres per kilometre per hour. But we've also put what we call the curly axis on. If you haven't heard of curly, go onto YouTube and look up combined real loss indicator. It's an IWA initiative, essentially. It's a way of reconciling the level of leakage in a rural area versus an urban area and coming up with one measure of leakage. But you can see that we've got some areas, some DMAs where the MAL level is tending down towards 0, and we've got others with very high levels of MAL. So if background leakage is as defined as a lot of small leaks, you would expect that to be more evenly distributed across the DMAs, whereas in fact we've got some DMAs with next to no background leakage and others with very high background leakage. So that was where we got our suspicion that maybe some of that background leakage is due to a small number of large leaks rather than a large number of small leaks. So the results so far, and this is just on the first 6 DMAs that we've looked at. And this is hot off the press from Friday, just before I sent the slides through. I'll try and explain it. We've got the total number of properties in those 6 DMAs, 3,237. Our estimate of the MAL was 38,000 or 38 cubic metres an hour, let's say. The night use, our estimate of the night use, excluding the plumbing losses, varied quite considerably from 2.53 up to 4.87, so almost 2 to 1 in terms of the night use, the intermittent use events. Then we have the estimate of customer supply pipe, customer side leakage, that's both internal and external, and again a wide variation from almost nothing in one DMA, 0.75, up to 10 litres per property per hour in another DMA. So we've then taken that, we've then estimated what the level of network leakage is. You can see in the first DMA, our estimate is that there is no leakage on the water company's assets. So that's mains and comm pipes, there's no leakage. Everything that you think is leakage is either customer use or it's customer side leakage. There's nothing on your mains, which again challenges this point that it's all a lot of little leaks on the mains. It's probably not. And then we've gone on, we've cascaded that across. If I take our estimate of the MAL level as 100%, you can see that we're saying that 28% of that is night use. The estimate of customer side leakage is 49%, and the estimate of network leakage is 21%. So what we're saying is of the MAL levels that we've experienced so far, only 21% is on your mains and comm pipes. On the customer side, the split of that 49%, if we take plumbing losses, internal plumbing losses is 1.4 litres per property per hour, that's 11.85%, and the underground supply pipe leakage would be 37.79%. We're going to keep this rolling table up to date as we work through the 25 DMAs and see what these values tend towards. What we have found is a lot of leaks on the customer side. So in the 6 DMAs so far, we found 223 customer side leaks that hadn't been picked up. What we do before we go in is that the water company does a traditional leak detection survey through the area. We found 223 customer side leaks, 135 small, which we class as less than 10 litres an hour, and we found 40 large, which are ones over 60 litres an hour. 60 litres an hour is still not a huge leak, but it accounts for 14 cubic metres an hour in those 6 DMAs. What we've also done is, now we've got the MAL levels, this is just for one of the companies, now we've got the MAL levels, we've then looked at the theoretical Mabel figures from managing leakage, pressure adjusted them, and looked to see is there a relationship between the pressure adjusted Mabel value and the actual MAL value. And I can't see a relationship there. Don't know if anyone else can. It just seems to be quite random. So we posed this question: is background leakage as defined in the managing leakage reports? And I'm sticking my neck out here, but I'm saying it's highly unlikely that background leakage is due entirely to small leaks below the detectable threshold as defined in both managing leakage and the Water UK route map. It's more likely that it's due to a combination of detectable leaks, errors in flow measurements, and errors in the estimation process. So the last few presentations I've done, I've been promoting this diagram to look at the MAL figure and think, well, is it leakage or is it not leakage? If it's not leakage, it could be night use above what the average level is. It could be plumbing loss above the average level. I think everybody I know works out an average level of plumbing losses and applies that to every DMA. We know that that's not the case. Some DMAs have high levels of plumbing loss and some have low levels of plumbing loss. It could be metering errors, it could be hydraulic effects. And then if it is leakage, is it undetectable leaks, which is the definition, or is it hidden detectable leaks that we're looking for? And could it be some growing leaks? There was a reference in a 2005 OCWI report to leaks in their early stage of development being part of the background leakage. So Judith was quite keen for me to go last so I could pose some awkward questions for you and stimulate some debate over drinks. So these are the points that I've picked up from what I've just said. I've said that we found a lot of small leaks, customer side, a lot of small leaks below 60 litres an hour. We've picked those up from our technology. When a water company person's gone to find that leak, they haven't found it. We don't know whether it's internal or external, but they just haven't been able to locate it. So if you can't locate it, you can't fix it, and you can't really do anything about it. So should that be included in your KPI level of leakage if you can't do anything about it? It's a question. How do we assess what the true level of DMA night consumption is? That's both night use and plumbing loss. If we don't have smart meters or we don't do a full stopwatch survey, because without that, you could have a misleading estimate of what the true level of leakage is in that DMA, and you could be making the wrong decisions on how to tackle that level of leakage in that DMA. Is there a standard way of reporting MAL levels? As I say, we've taken the 5 percentile value over 3 years, but is that the right thing to do? Next bullet point, big one. We've heard a lot about mains replacement. Is the evidence there to show that mains replacement reduces background leakage? I was challenged by someone from Brazil over a previous presentation on this, and he said, well, we've reduced background leakage. Let's have a call to discuss it. The way they'd reduced it was to replace the service pipes. Not to replace the mains, but to replace the service pipes. What's the impact of smart metering? It might sound obvious and everybody's gone for smart metering, but has it been thought through? How granular, what's the granularity of the data that you're going to get? The smart part of smart meter is about the communications technology. It's not about the accuracy of the meter. So are those meters going to pick up these small continuous flows that Dean's referred to and I've referred to? And are the managing leakage values useful for estimating Mabel at a DMA level? I mean, I've just shown that graph. I would start to question where they are. At a larger zonal level, where everything averages out, possibly, but not at a DMA level. That's me.
You okay to take a few questions?
Yeah.
Okay, well, let's throw it open to the room. First of all, that's quite a challenging set of questions at the end there, isn't it? We're all wasting our time on mains renewals.
I didn't say that. I didn't say that, Bob.
Well, that was the implication. Anyway, there must be some questions from this in the room. Or are you all too tired and you want to just go for a glass of something cold?
Or dare you not ask?
Ian, have you got a question here?
No, I was just saying I'll write down what you said about mains renewals.
I'm talking about mains renewals and background leakage, not about burst frequency or asset health or anything else. I'm talking about, the relationship between mains renewal and reducing MAL levels.
So there's a question down the front here. The mic's on its way.
I was just going to ask, because you said you couldn't find some of the stop valves on those blocks of flats and all that. Did you just move to a whole area, or did you include all that in your data?
We went to a different area. I mean, the reason we've gone for areas of 700 properties with little or no commercial use is so that we can take that out of the equation. And where we have blocks of flats, you can get overlapping use events that look like continuous flow. It makes our stopwatch technology more difficult. So we can cope with small blocks of, say, 4 properties from a same supply. But once you get above that, again, you get the use events starting to overlap and look like a continuous flow.
I just wasn't sure if you included that in your data, or we just moved on from it. That was all.
We're just trying to take out as many uncertainties as we can and just say, look, here's an area where we're convinced of the boundaries, we know the housing stock, we're not thinking about commercial use and everything else. But we've got this level of background leakage. What is it? Where's it going?
Okay, any more questions from the floor? I'd like to ask you a question, Stuart. I think you touched on. You touched on there in that final set of questions. So we're all embarking on smart metering, aren't we?
Yep.
And obviously there's a positive impact there on plumbing losses, customer side leaks, and so on. So clearly there's a customer dimension there. But I think, as Dean said earlier, customers don't seem to be concerned about having to repair leaks. They're happy to go ahead with that. It's the efficiency part of it that's more of a challenge. So my question is smart metering going to solve our leakage problem?
I'm in favour of smart metering. If you may have got the wrong impression, I'm in favour of smart metering because at least that way we'll know what the true level of consumption is. Question mark over whether those smart meters will pick up all of the small flows. But the point was raised earlier in the day. If we're alone in the UK of reporting customer side leakage, including customer side leakage in our KPI. Mm-hmm. I think I'm supportive of just reporting leakage up to the boundary, and anything that goes through the meter, which is what the rest of the world do, but goes through the meter, it's not our problem. It's not our problem.
Yeah. Okay. Any further remaining questions? We're running rapidly out of time, but we've probably got time for one more. Okay. Well, that remains for me to thank Stuart for a really stimulating presentation. Thanks, Stuart. Okay, so that brings us to the end of today's proceedings. We have the dinner at 7:30, which is in this room, same room. Obviously, it'll look a little bit different than it does now. I'd like to thank all of the speakers today for their really top quality presentations and for everybody's contributions, all the questions that you've asked of those presenters. I'd like to thank all of the exhibitors. Have we got the slide again to show all of those exhibitors as we did this morning? And thanks to, as I said, thanks to all of you for contributing. So I think the bar outside here is open. We're back in here for 7:30. We've got a special guest speaker over dinner, over the meal. We'll talk about that a bit later on. But see you here in a little while. Thank you very much.